Alright, we now want to connect the following. We want to connect the point 0.08 to 5.2. We've got to use a different graph other than the ones we've used. We've already used the parabola and we've used the cubic function. So what I'm going to do is I'm going to utilize the hyperbola. The hyperbola equation that I'm going to use is y equals k over bx minus p plus q. Now remember, these are all letters. I'm changing the letters around. You might use A, B, C, D all the way across. It's up to you, but this would be the general equation that I could use. And notice that I have two unknowns over here, and I have 2 points that I need to get it to go through. If I stick with this equation, the first thing I need to do is identify what my asymptotes would be. Now, a hyperbola, if I have a y-axis and I have a x-axis and I have a dotted line running around here, it's going to be my p-value, and a horizontal dotted line running across will be my q-value, and so that will be the central point PQ, which will be where my asymptotes meet. Now these asymptotes I'm going to create by just looking at this, and let's say I want to recreate the top right hand side of this parabola to be that. Hyperbola to be that. Alright, so this over here, I want that to be over here. In which case I need to create an asymptote, some asymptote on the left hand side, anywhere on the left, and some asymptote at the bottom of that point as well. And I'm going to choose for myself -1 and +1. So I'm going to say PQ. I'm going to let P equal to -1 and Q equals to +1 as my asymptotes. I'm going to substitute this into the equation. I get K over Bx. Now -1, remember, is going to become +1 at the bottom there, alright, because it's a positive. And then at the same time, Q is going to be +1 as well. Now, technically 1 over b is actually my asymptote, because if I take this bx plus 1 and I make it equal to 0, then I notice that x plus 1, or bx, is equal -1, right? And so x will equal -1 over b. In other words, p over b is actually going to be my asymptote. Alright, but not to confuse you, let's say we did this and we went with this. I'm now going to substitute the point. Let's start with 0.8 first. This point here. Okay, x is 0, y is 8. That becomes 8 equals to k over 0 plus 1, because 0 times anything is 0 plus 1. That becomes 7, and so k equals to 7 for this. And then at the same time, I then substitute that back into the equation, and I need to find b now. So if I do substitute b, I want to make sure that I get the right number here, which is going to be 5.2 in here. And that would be, if I make x equal to 5 and I make y equal to 2, then 2 will equal 7 over 5b plus 1 plus 1. 2 minus 1 is 1. 7 over 5b plus 1 multiplied to the other side. 5b plus 1 equals 7. 7 minus 1 equals 6. And so b equals 6 over 5. In which case I can then get to a final equation, y equals to k, which is 7, and b is 6 over 5x minus p plus q, which is going to be +1, +1. Now I suspect this might not work. Let's have a look why. I'm going to erase this line here and this line here. And so if I got y equals to 7 divided by 6 over 5 x plus 1 plus 1, then it goes through perfectly. So that works out absolutely perfect. Don't forget the domain. The domain starts at 0 and it's less than or equal to 5. Okay, x. Press the less than equals to immediately after that, and then 5. Close it with a curly bracket, and now we've connected 2 dots. Okay, so let's go through the process of how we did this. The first thing is we located the p and q value, and we did that by creating hypothetical spaces, one from the left of the year and one down from this point, so that it resembles the hyperbola of what the hyperbola should be. I use the equation k over bx minus p plus q, and I substitute the point of intersection of these two, remember that? So this is the point of intersection, which is that over there, and that was pq there, and that's my first part. So that's part of the features of this graph. This is your -1 is going to be a vertical asymptote that can be mentioned, and also q equals +1 is my horizontal asymptote. After I substitute them in there, you can see they've gone in. I then substitute 0.8 because it's a known point. It's a known point that I want it to lie on. Okay. By doing that, remember, I do have two unknowns, alright? If I do 0 and 8, I substitute it in there, you notice that b disappears nicely, because 0 times b is 0, which gives me enough room to just find k alone from here. Okay. And then I move on from there, substitute the next point in, and the next point is going to be 5 and 2. And so at this point here, I'm substituting x equals to 5 and 2, which is the other point, such that b is created to accommodate the point 5 and 2, after it has already accommodated 0 and 8, bringing this final part here. And I can simplify this into a more a non-fraction form by taking the 5, multiplying it on the other side. So if I took 7 and I put 6x plus 5 times 1 is 5, and this is all over 5. If I have to convert this into a fraction, plus 1, and in tuple times, or 7 over 1 divided by this will become 35. So this can be rewritten as y equals to 35 by taking the 5 times 7, 35 over 6x plus 5 plus 1, if we need to write it in a more appropriate form. And that should be exactly the same answer. We can check. Okay, so I'm going to go y equals to 35 divided by 6x plus 5 plus 1. Okay, and if I take that out, I can see that my domain can also be there. I don't need to provide both. I think one would suffice. The second equation is more appropriate because there's no fractions in the denominator. It's more easier to read as well, and it also goes through the same points. So if you look at it, look at what I did there, you can see that I've created the same equation in different forms by just rearranging the equation, which I can do, but I can do that at the end. I don't have to do that. Once I've got an equation that works, to save time, I would just move on to the next part. Alright, we got our asymptotes. It's also, remember, the k value is positive, so it's in the top right hand corner, bottom left hand corner as well. And our domain is given, the domain automatically restricts the range. So by stating a domain, it automatically restricts the range as well. So we just state the domain, it'll be good.